This is the procedure for the determination of our lab. We're going to create a sample of hydrogen gas by reacting solid magnesium metal with hydrogen ions, which will be provided by an HCl solution. So we're going to take 6 total measurements during this lab, and that'll allow us to determine the pressure of the hydrogen, the volume of the hydrogen, the moles of the hydrogen, and the temperature of the hydrogen, which will then plug into the ideal gas law to determine the value of R experimentally. First measurement is very easy. You just simply get the mass of a strip of magnesium metal on the scales that measure to 4 decimal places. And when you go to do the calculations, you're going to change the grams of magnesium to moles, and then if you look up here at the balanced equation, you'll see that the ratio of hydrogen to magnesium is 1:1, so the moles of magnesium will be equal to the moles of hydrogen using stoichiometry. That does assume that you don't lose any hydrogen in the process, so you want to do what you can to not lose any hydrogen bubbles as the reaction's going on. For the experimental procedure, you're going to take a gas measuring tube and add about 10 milliliters of HCl solution. Whoever's doing that step needs to wear gloves, and that'll be the case all year. Anytime you're working with acids, make sure you have gloves on. Then you're going to take a squeeze bottle of distilled water and add distilled water until the tube is completely full, so almost to the point where it's overflowing, to make sure there's no air at all left in the tube. Then you're going to take the magnesium and you're going to curl it into a ball and wrap it in copper wire. Then the extra copper wire you're going to feed through a rubber stopper that's going to be used to cap the end of the tube. And then you just hook the extra copper wire over the edge of the tube. So I'll demonstrate how to do that in the lab just before you begin your experiment. Once that's all set to go, whoever's got the gloves on puts their index finger over the hole in the stopper at the top of the tube and flips the entire tube upside down into a beaker of tap water. You want one of those large beakers around 400 milliliters, maybe about 4/5 of the way full of tap water. So you flip over the tube into the big beaker and you clamp it in place with the stopper about 1 inch from the bottom of the beaker. At this point, your setup looks like this. The HCl was at the bottom of the tube. It's now up here, and it will make its way downwards, eventually coming in contact with the magnesium here. And when that happens, you'll start to see bubbles of hydrogen gas, which will move straight upwards, and you'll trap it in the tube. When you stop seeing bubbles and the reaction's over, that's when you can start to take the rest of your measurements. So the second measurement is to get the volume of the hydrogen to the nearest 0.01 milliliters. The tube has volume marks, starts at 0 here, and you just want to measure the volume of the hydrogen to the nearest 0.01. Next thing you want to do is get the temperature of the water in the beaker to the nearest 0.2 degrees Celsius, and we're going to assume the hydrogen temperature is equal to that. So just stick a thermometer in the beaker and get the temperature to the nearest 0.2 degrees Celsius. The next 3 measurements are going to help you get the pressure of the hydrogen gas. So measurement 4 is simply to get the barometric pressure to the nearest 0.1 millimeters of mercury. Remember that when you collect a gas over water, there's not only the gas you want, but water vapor mixed in. So measurement 5 is to get the water vapor pressure, and you'll do that. There's a chart on the wall in the lab. You just go over to the chart, find the temperature that you've measured to the nearest 0.2 degrees Celsius, and write down the vapor pressure from the chart in millimeters of mercury. And that'll be helpful later on when you go to calculate the pressure of the hydrogen gas by itself. So that's measurement 5. measurement 6, you'll notice that the level of the water in the beaker and the level of the water in the tube are different. That means the barometric pressure is larger than the pressure of the gases in the tube. So you want to measure that pressure difference by measuring the height from the level of the water in the beaker to the level of the water in the tube. You measure that height by getting a ruler and figuring out the height to the nearest 0.1 millimeters of solution. And I underline solution because, to remind you, it's not millimeters of mercury you're measuring, it's millimeters of solution, so we're going to do a conversion in the next step. So now we have all the measurements we need to figure out R. We just got to do a few small calculations to get there. First thing is the pressure of the hydrogen. We're going to take the barometric pressure that we measured in millimeters of mercury. We're going to subtract off the water vapor pressure, also in millimeters of mercury. And then we're going to subtract the height difference. But remember, it was in millimeters of solution, so you're going to want to divide by 13.6 to convert it to millimeters of mercury, and then you can do the subtraction. So it's barometer minus water vapor minus the height in millimeters of solution divided by 13.6, and that'll give you the pressure of the hydrogen in millimeters of mercury. So at this point it becomes just like a homework problem. You need to change the pressure from millimeters of mercury to atmospheres, the volume from milliliters to liters, the temperature from degrees Celsius to kelvins, and of course you already have the moles from stoichiometry. So you plug them in, you figure out the value of R, and you want to make sure to show a unit on your final answer for R. R has a unit. If you plug in each of these four, pressure, volume, moles, and temperature, you'll get the correct unit of R. As always, when this lab's going on, you should be writing down any key observations that happen. Those will help you to discuss sources of error later on. But you pretty much you have everything you need to calculate R, and the final thing is to figure out the percent error, which is taking your value of R that you determined in the lab and subtracting the accepted value that we use on the homework, so 0.0821. Take the absolute value, so if that difference is negative, make it positive, and divide by the accepted value of R that we've been using, 0.0821. So absolute value of the difference between your value of R, the accepted value of R, and then divide by the accepted value of R and multiply by 100%, and you'll get the percent error. That's really a measurement of how accurate you were in the lab, how close you got to the accepted value. So hopefully that'll be a pretty low percentage, maybe less than 5% or so. But that's everything you need. Good luck, and we will see you in the lab.